Okay, we're going to talk about probability in this lesson. This is lesson 1-6 in your book. So the first part of probability that we're going to talk about is experimental probability. And experimental probability means you do an experiment, and the number of times the event occurs divided by the number of trials gives you the experimental probability. So here's an example. And this is actually from your textbook. It's not because I went to UT. When the University of Texas won college football's national championship in the 2006 Rose Bowl game, I went to UT at that time, not important. Its quarterback completed 30 of 40 passes. Find the experimental probability of the quarterback completing a pass. So, probability that he completes a pass is equal to 30 out of 40. It's that simple. Number of times he attempted it divided by, number of times he attempted it is your sample space. It's what goes on the bottom. And the number of times the event occurred, he completed it 30 times, is what goes on top. So 75% or 0.75 is the experimental probability that Vince Young, that was the name of the quarterback, will complete a pass. Okay, that is theoretical probability. There we go. That was experimental probability. Now we're going to talk about theoretical probability. So a theoretical probability, I've got a picture of it. This yellow circle represents all of the possible outcomes. Okay, they're equally likely. Any of them could happen. The orange circle represents some outcome that you're interested in. The theoretical probability is you take M, the number of outcomes, the number of ways that could happen, that event A could happen, and you divide it by N outcomes, the number of outcomes total that could possibly happen. So that's the definition of theoretical probability. Let's look at an example of that. Alright, so the first thing is we want to know what is the size of our sample space. I'm going to write that as S. Let's look at the problem. Find the theoretical probability of getting an even number when you roll a number cube. So the size, a die, is a number cube, and die is singular for dice. So they're talking about a regular six-sided die, I'm assuming. So there are 6 sides to this die. I'm going to hit roll a couple of times. Alright, so there's 6 different possible outcomes. So the sample size is 6. Find the theoretical probability of getting an even number. So we're interested in getting an even number. Well, you can get an even number by getting a 2, a 4, or a 6. That's the only ways that you can get it. So the size is 3. There are 3 ways that you can get an even number. So the probability that you get an even number is equal to 3 out of 6, which is 1/2, or 0.5, or 50%. 50% chance that you'll get an even number. Okay, so I want you to go ahead and do this. Fold your hands so your fingers interlace. Alright, so now look down and see, is your left or your right thumb on top? 75% of the time that you do this, your left thumb is on top. We'll actually do this in class to see how accurate this is. But your left thumb on top is a genetic trait. So that means 3 out of 4 times. So if you remember these things from biology, okay, so you have the dominant trait and then the recessive trait. Dominant, recessive. You get, just kidding, only 1 out of 4 times would you get your right thumb on top. So the theoretical probability, you have 4 possible outcomes. 3 of the 4 would give you left on top. And so that's 75% of the time you would get left on top. That's the theoretical probability. Now, what probability means is if we did this many, many times with many different people, about 75% of them would put their left thumb on top. It doesn't mean that 75% of 4 people, so if we did it with 4 people in class, it doesn't mean we're guaranteed 3 of them will put their left thumb on top. It just means in the long run, if we did this many, many times, 75% of the people would put their left thumb on top. Okay, now we're going to talk about geometric probability, and we're going to play around with this quite a bit in class, but I'll do one example of this here. We have a dartboard. We're going to say each of these are the exact same width apart. I didn't do that well in my picture. I mean, this is obviously longer than that, but I was attempting to do that correctly. So, each of these have the same radius, the same width, or r of each ring. We want to find the probability of it scoring at least 10 points. So the first thing we got to figure out is our sample space. Our sample space is the entire dartboard. Okay, this is our sample space, the green. And then our event that we're interested in, the probability that we get at least 10 points. Well, we get at least 10 points if we land in here. So in order to figure out the probability, we're going to have to do some geometry. So the first thing is we got to figure out the size of our sample space. Well, our sample space is the size of the area of this circle. Well, this circle has 1, 2, 3, 4 radiuses. So it's pi r squared, and r is 4r in this case. Area is pi r squared. And so our sample size is 4r times 4r. This is the same thing as saying this. It's 16 pi r squared. Okay, that's our sample size, 16 pi r squared. Then the area of this other smaller circle that we're interested in, this one right here, okay, its radius is 2r. So the area of the smaller circle is pi times 2r squared, which is pi times 4r squared, or 4 pi r squared. So the event that we're interested in is that we get at least 10 points. So the area is 4 pi r squared. So to figure out the probability of E, we put 4 pi r squared over 16 pi r squared. And then we simplify. The r squareds cancel out, the pi cancels out, the 4 over 16 simplifies to 1 over 4, or 0.25. So we have a 25% chance, if we're just throwing the dart and it could land anywhere, which is what it says. Assume that everything is equally likely to be hit, so you're not good at darts. Then you have a 25% chance of landing in here. Okay, I believe that's it.